Is it recording? There we go. All right. Welcome to week 2, day 2. We're going to pause in our discussion of if statements. We're going to give you a little lab time on if statements today, but we're going to not really teach a new thing on if statements today because I have issued your second week's Zybooks, and the second week's Zybooks talks about a topic that I usually cover in week 3 or 4. And so today I'm going to cover it a little bit earlier, which is how to use functions. Functions are like algebraic functions in this case. In fact, most of them are like sine and absolute value and exponentiation and things like that. Before we do that, I would like for you all to write a program. We're going to do some lab time right off the bat here. And I want you to write a program that will do the following. Step 1, ask the user to enter a float, and then you will read this floating point number into that variable you made. I should say, make a float variable, read this floating point number into the variable you made from the keyboard. And then I want you to print out the absolute value of that number. For example, if they type in 5, you output 5. If they type in negative 0.2, you output 0.2. Okay. So I'm going to give you 20 minutes to do this. Now, what I found from the previous class was that, the people that have been doing the Zybooks were a lot more fluent with this than the people that have been putting off the Zybooks. This is one of the reasons why I didn't really want to make the first Zybooks due like at the end of 2 weeks, because a lot of people wait to the last minute to work on Zybooks, and as a result, they were like, I have no idea what I'm doing. Like, I can't even begin on this. And if that's the case, you're going to need to message one of the helpers, Cabrera is here, for example, and be like, yo, I just, stream your screen and we will work with you. I don't want you just like staring at a blank screen, because it's not going to get better. Okay? It's not going to get better. And then the other half of the class was like, okay, I know how to make a variable, right? That was what we worked on the first day we learned C++, how to make a variable. In this case, it's going to be a variable of type float. And then we've learned how to do input and output, how to see in into a variable, how to see out from a variable. And if you don't remember, just ask. Post on the Help Center. This is not like a homework. You can plagiarize each other just fine. Like if somebody's like, hey, my code's not working, like I'm doing C out X like that. It's not working. Yeah, and people will be like, yeah, it's because the arrows have to go that way. It's a mistake that probably half the class has made today, like, make sure the arrows are going the right way. The less than greater than sign. Okay. And so yeah, just edit a new file. This is going to be graded, but I want to see every person in this class screenshot their code and post what they have at the end of the 20 minutes. And I don't want to see just a blank file, because that means you were sitting here for 20 minutes without asking for help. It's really, really important. Again, in computer science, to ask for help. In person, I can walk around and see when somebody's staring at a blank screen. Online, I don't have that ability to teleport, So if I see a blank screen in your screenshot, and don't think that like I'm not going to notice you didn't screenshot something. I'm actually going to go through the list of every person online right now and verify that they posted a screenshot. Okay, so just do what you can. Try and get this done in 20 minutes, beginning now. And I'm going to pause the recording now, because 20 minutes of dead space is going to be quite boring. But I want you all to be actively working. And if you finish early, work on your Zybooks. There's Zybooks week 2 is twice as long as the first one. And so if you've been putting off the Zybooks, try and get Zybooks week 1 done now. And then start cracking on Zybooks week 2, which is due a week from today at noon. Okay. And it's quite expansive. And the reason why I do that is because, again, learning to program is like learning a foreign language. When I took Japanese, if I would go to class, kind of like sit in and be like, okay, I kind of understand the grammar, I go home and like study for like 10 minutes, then like get distracted by video games and things like that. You don't learn. You don't learn. The only way you can actually learn a foreign language or learning how to program is to program. You have to program constantly and have the computer tell you, no, that's wrong. And then you got to fix it. You just have to constantly be outputting code onto the screen that is correct and readable. You do that enough and you get good. If you don't do that, there's nothing I can do to help you. Even if you sit in on every class, you're not going to learn how to program. You're not going to be capable and competent. You have to do the Zybooks, especially those little labs. You do 5-6 of those on top of the one homework assignment I do per week, and you're going to be a very competent programmer by the end of the semester. Trust me, I've been doing this for a long time, and I've even run the stats on it. For people who do Zybooks, like their performance is much better than the people who don't. So if you can't afford it, sign up for the 2-week free trial, and that'll at least cover you for the first 2 weeks, and then you can hopefully come up with the $70 by then. And EOPS and other programs, Trio, are there to also help with the textbook costs as well. Okay, so 20 minutes from now is going to be 3 o'clock. I will pause recording, and I want you all working hard. Get the lab done, and if you get the lab done, get your Zybooks done. All right, looking at your code, it's looking pretty good. Some of you posted it, and I can tell from the fact it didn't compile. You either didn't compile it, or we're okay with it not compiling, maybe. Let's see here. Yeah. Okay. So, step by step. Ask the user to enter a float. Cout. Please give me a float. Make a float variable. Float root beer. And of course, initialize it. Read this floating point number into that variable from the keyboard. Okay, so cn into root beer. Root bear. Better. Print out the absolute value of that number. Okay, so a couple different ways you can do that. You can do something like this. If root beer is less than 0, root beer is equal to root beer times -1. And for those of you that remember our lecture from last time, you might be like, oh, there's a faster way of doing that. Okay. So we could do this instead. Other ways of doing it. Seems pretty straightforward to me. Okay. And then we are going to output the numbers. Cout root beer. Why root beer? Oh. Root beer floats. Pretty good. Okay, so that right there is the heart of the program. Where if you type in -5, this will turn it into 5. A lot of different ways you can do it. There's not like one, right way of doing it. As long as your code works, that's all I care about. Okay. So there you go. I'll screenshot that for you all. Looks like most people posted their code, so I don't have to go after anyone. Public humiliation. That's fine. So Windows key Shift S, and that'll take a screenshot if you're using Windows. Yeah. So this code here, you're copying. Okay. Yeah, you don't need to do that. So this code here, yeah, the top 3 lines there, you just copied kind of blindly, I think. All you need is #include IOStream. Yeah. So else A equals A, you don't need. Now, a lot of people did that in the previous class. They said like else root beer equals root beer times 1, but multiplying a number by 1 is the identity operation. It doesn't do anything. And a lot of people tried doing this. Else root beer greater than or equal to 0. And that is not good C++. The else statement takes nothing. And the reason why it takes nothing is because it uses the if statement's Boolean expression, right? This Boolean expression here will evaluate to either true or false. Either root beer is less than 0 or it's not. And if it's true, this branch runs, and if it's not, this branch runs. So else does not have its own thing. Okay? And that's a very common mistake that people make around now in CSI 40. They try to put one of these things after the else. It doesn't. The else uses the ifs Boolean expression, right? So you come to that point, you either go left or you go right. You know what I mean? We will learn probably next time the else if, which is probably what a lot of people are trying to do. But yeah. So yeah, Romero, your approach there is perfectly workable. Let's pull that up here. Please enter float. Read in a value. If the value is less than 0, you got to put that value times -1. Otherwise, you got to put the value. Just fine. Just fine. Again, you don't need these 3 things here. This is all you need. And that probably is worth mentioning. So what is this? Who are you? I wonder if that's just the edge of the wallpaper. Not weird. Which is this include thing here. So the core C++ language is actually quite small and quite compact. There's actually not a whole lot of things in the core language of C and C++. If you don't include anything, there's actually very little you can do. There's a surprisingly small amount of things you can actually do if you don't include anything. And that's the core language, okay? So things like making a variable, doing algebra, if statements, that's all part of the core language. Pretty much, and then we're going to learn for loops and functions and things like that, but pretty much anything interesting that we're going to be doing is going to be using something called the standard library, STD for short, stood for short. And in order to use those parts of the standard library, you have to use an include statement. In the near future, they're doing something that I've wanted for a long time, which is this. You're going to be able to just import stood like that. And that's going to be next year. And I'm very excited for that. I've been wanting that for 30 years or so. And then that'll just bring in the entire standard library for you, and you don't have to worry about this include nonsense, which is kind of terrible. But as it is, if there's something in the standard library you want to use, you have to include it. So cin and cout are found in iostream. The absolute value function, which is what we're going to learn today, is found in Cmath. Okay, it's the Cmath library from the C programming language. And that's kind of our topic for today, is using math functions built into the standard library, so you don't have to write it yourself, okay? So what we can do instead of all this kind of stuff here is, instead of writing absolute value ourselves, we could do this. So if you're familiar with the notion of functions from algebra, this is a function whose name is abs. Never skip abs day, right? And it takes, you pass in a parameter to it, root beer, and then it returns a value back out. Like if you've ever taken algebra, you can have f of 5 or something, right? So 5 is the parameter that you put in, and then the function does some computations, then it spits a number out. And so in this case, abs spits out the absolute value of root beer. And this code will be exactly the same as the code I had before. If I type in -1, it gives 1. If I type in -1,000, it gives 1,000. If I type in 1,001.1, I get 1,001.1. Exactly the same code, less typing though. And I know a lot of you wanted to use abs right off the bat. I wanted you to write it the slow way for a reason. In the future, just use the function. I wanted you to write it the slow way for 2 reasons. One, it's good practice with if statements. Like I said in the previous class, a lot of students were trying to put a Boolean expression after the else, which it doesn't take. And it's just a great way of getting familiar with writing code. You have to just write code constantly to get good. Okay? You have to. You have to produce code on your own and independently, right? And, maybe having people posting their screenshots was destructive to those means, because you just kind of be like, oh, that's how they did it, And everybody was copying, the first 3 lines from my thing, right? Like Pina had IOStream. Etheridge Smith had IOStream. Aaron Teffer had IOStream. Andreas had IOStream. Okay. So about half the people just kind of copied my header. Yeah, all you needed was IOStream. So like, yeah, when you can see each other's source code, you can copy off it, and that's kind of a good thing, bad thing. I really want you to be able to just make this from scratch. You have to be able to make it from scratch, be able to produce, code out of the dark recesses of your brain, somewhere in the back where your brain stem lives, Deep within there, you need to bury the code, and then you can just produce it at will and tap into the matrix, become one with the mainframe. In all seriousness, like you should be able to just erase this whole thing and do it from scratch without looking at anything. Eventually. That's why we do practice. And then the second reason was to show you that using a function is much simpler, right? So rather than having to write an if statement, flipping the sign or whatever, we just be like, yo, abs, done, right? And that's what's nice about using these standard library functions is that they do a lot of the heavy lifting for you. Now, this is very important. I'm going to show you a website that I want you to become best friends with. Okay? This is the most important website you're going to use in this class. It's called cppreference.com. It is like a wiki specifically for the C++ language. And it's got everything in the core language plus the standard library in it. The core language is just this little bit over here. And then all the other stuff over here is part of STD, stood, the standard library. There's a lot more stuff in the standard library than there is in the core language. The core language you can learn pretty easily. Like you can learn the core language in a couple of weeks, honestly. When you take CSI 41, we spent a lot of time going through the standard library because it's kind of like one of the things that separates out new programmers from experienced programmers is that a new programmer will try to do it themselves, right? It seems paradoxical, right? Like you think an experienced person could try and do it by themselves. No. The new programmer is like, okay, I need to come up with a function for the greatest common divisor. Okay, so if they type in 15 and 20, the greatest common divisor is 5. So maybe I just subtract 20 minus 5, 15. Sorry, if you have 15 and 20, the greatest common divisor is 5, so 20 minus 15 is 5. Maybe it's subtraction. No, that doesn't work for all the cases. And you sit there for like a week trying to, redevelop Euclid's, method from scratch. And then the experienced developer walks by and is like, what are you doing? Like, I'm trying to, come up with a good algorithm for finding the greatest common divisor between two numbers. And the senior dev's going to be like, why aren't you just using the function for it? It exists. Just use it. Like. Yeah. So, yeah, there's a header file called numeric, and there's a function in there called GCD, greatest common divisor. And you just pass in two integers, and it tells you what the greatest common divisor is. Why write it yourself? It's done for you. And so experienced programmers will just be like, oh, I need a greatest common divisor. Bloop, GCD, done. Move on with your life. And then the new guy is like sitting there for like a week, like trying to come up with these cool, super optimized algorithms, not knowing that Euclid invented a pretty good method for doing it 2,000 plus years ago. And I was that guy. The junior programmer that I'm talking about was me. Yeah, I thought I had made a better algorithm than Euclid's method, and I had not. Almost did. I was very close actually to reinventing Euclid's method, but I had a bug in it. Yeah, it's just use it, right? So like that's our topic for the second half of class, which is become friends with this webpage. It's got references for all the stuff in standard library. And like I said, in 41, we're actually going to take the time to go through it and kind of like learn the stuff. For now, though, just be aware that it exists. And if you ever need to look up something like, hey, how do I compute how do I round a number in C++? You can just, type round up in here, or you can look through the common math functions here. And there's abs, and there's all sorts of functions in here. E to the x power, 2 to the x power, log log base e, it's ln, log base 10, log base 2, pow. This is something that always gets me programmers. Let's see. Float x equals 0, y equals 0. Please enter two numbers. And I always like to tell people, I always like to prompt them when I'm waiting on them. Because if you don't do that, then it just sits there, And sometimes you're like, all right, is the program loaded yet? Like, what am I waiting on? And you're like, hello. So it's always a good idea to always prompt the user so that you know that, two numbers. Okay, thank you. 10 and 20. Now, I want to compute x to the yth power. Now, one thing that students almost always try is they try this, and don't do this. Like, please, if you have this screen shotted, no. Don't do this. I'm showing you something very bad. See how x to the yth power, right? Right? No, it's not exponentiation at all. It's not exponentiation at all. It is something completely different. It is doing, yeah, okay, fair enough. Let's make this an int. Let's compute 2 to the 10th power, and we got 8. It's not exponentiation at all. It's the XOR bitwise operator. It's flipping bits. Has nothing to do with exponentiation. And so the actual way of doing this is using a function called pow, like the pow block from Super Mario Brothers. So this says take x and raise it to the yth power. Okay. So we do that again, and we say what is 2 to the 10th power? We get 1024. Right? We say, hey, what is 2 to the 20th power? We get about 1 million. Right? 1 times, this is 1 times 10 to the 6th power. It's about 1 million. Okay. But if we take 2 to the 30th power, it's about 1 billion. Right. But if we take 2 to the 40th power, it's about 1 trillion. But not exactly. And this is why hard drives oftentimes have about 10% less hard drive space than is advertised, because they advertise it in powers of 2 or powers of 10, whichever way benefits them more to make the drive look bigger. But then it's actually the smaller thing. So there's something called a gigabyte, not a gigabyte. They're not exactly the same thing. A gigabyte is like 10 to the 9th. Yeah. And a gigabyte is 2 to the 30th. They're close to each other, but they're not exactly the same thing. And so storage people that make memory sticks and hard drives typically pick whichever one of those two makes their thing look bigger. And then you put it into your computer and smaller than was advertised. A little bit of deceptive advertising there. Okay, so pow. Do you all understand pow? So this is a function, and you pass in 2 parameters to it. It's kind of like an algebra. You can have f of x, y, and that kind of stuff. You pass in 2 numbers. And then it does a computation, and then it returns the value back out. Does this make sense? Is this pretty straightforward? Hopefully. Cool. So what other functions are there? Cool. Pow. There's a lot of stuff in there that I don't know, by the way. Yeah, like, I don't know. I'm sure it means something to someone, There's all sorts of things in here. Let's see. Trig stuff: sine, cosine, tangent, arc sine, arc cosine, arc tangent. These are actually kind of useful. So if you want to round an integer, round a floating point to the nearest integer, you can use round. And then there's ceiling to pick the integer above the current float you're at. So if you pass in 3.3 to ceiling, it returns 4. And floor is the opposite. So if you pass in 3.3 to floor, it returns 3. And then round gives you the nearest integer. That comes up a lot. But like, I don't know. There's a lot of kind of weird math functions in the standard library. The beta function, the modified cylindrical vessel. Like, don't ask me what these are for. Like, it's like the CPP reference just sends you to Wikipedia. So like, yeah, all right, give a different amount. Just once. I want to donate just once to you. I want to donate a negative amount of money. Now, you might notice I can't type a negative here, but that's actually a JavaScript function. And if you disable their JavaScript, you can actually punch in a negative number there, which is quite hilarious. Okay, so there is the Bessel function, I guess. Yeah. What's it used for? Applications, diffraction from helical objects, including DNA. Okay, so there you go. So somebody has some uses for those things. I don't really. So the things you should know. Let me just put it in here. Please enter a number. So functions you should know. Pow, which is exponent. And then there's lots of variations with like e to the x, logarithms, and such. Sine, cosine, tangent, like trig stuff. Abs, fabs. Actually, you don't need to know fabs. I just like typing fabs because fabs is a hilarious name. It's fabulous. It's totally fabs, man. Abs is absolute value, of course. And then there's labs and Lola labs and flabs. Flabs is what happens when you don't go to the gym and don't get abs. You get flabs. Nah, actually, I don't think flabs is a thing. What are some other good ones? Yeah, round. Round's important. It's like, you do something like this. See out round x. So if I type in 3.3, I get 3. 3.5, I get 3. 3.6, I get 3. Maybe I should make this a float again. I forgot that I changed it to an. Okay, let's try that again. 3.3, 3.5, 3.5, there we go. 3.6, negative 3.5. Okay. So 4. So that is round. It only makes sense with floating point numbers. As you can see, it works with an int, but there's kind of no point because it'll just round it to itself. If you pass in 5 as an integer, it gives you 5. If you pass in 6, it gives you 6. So round is pretty useful, I would say. Use it all the time. Mincorelli, any other Cmath functions that are important? Oh, square root. Yeah. So square root. We use that one a lot. So in our remaining 8 minutes of time, I would like for you.
And seal, sir.
Which one?
Seal.
Seal.
C-E-I-L. The ceiling.
Seal. Yeah. There's also floor and seal. Seal. I don't use seal as often as I use round. Round's probably the most common. Okay, so for the remainder of class.
Ooh, how about higher pal?
Okay. So please enter 2 numbers. And I want you to output the two sides of a triangle. Okay. So I'll put the length of the hypotenuse. Okay. So I want you to compute the length of the hypotenuse. So if you have entered the two sides of a right triangle, I should probably say. Right. So here, where my browser is. Get over here. Come on. All right. So if you have a 3, 4, 5 triangle, something like that. So what I want you to do is I want the user to type in two of the legs of the right triangle, and then you output the length of the hypotenuse, and use the powers of mathematics to do so. So you're probably going to involve square root, maybe involving pound. Okay, so you have 6 minutes. Or no, actually we have 16 minutes. So maybe I'll call you back after about 10. So at 3:34, I'd like for you to all have a screenshot on Discord showing me that you can read in two of the sides of a triangle and output the length of the hypotenuse using the Pythagorean theorem. Okay. Pythagorean theorem. All right. So see if you can figure it out. All right, I'll pause the recording now. If I can find my screen. Where's my screen? There we go. Okay. I'm liking it on here. I'm liking what I see. Let's see here. So you don't need to put parentheses around the square root here, right? Or these parentheses. I mean, they don't hurt anything, but they don't really do anything, right? It's just like in algebra. You can put I don't know, parentheses around a 5 or something. Doesn't really do anything. That's 5. Okay, so if you want to do that, I'll just do that and call it a day. All right, so the hypot function is the Pythagorean theorem. It comes up a lot in computer science, so they actually added it to the standard library. So you can do it the longer way, which is something along the lines of the square root of x times x plus y times y, or you could use pow if you wanted to. I think pow's a little bit overkill here. So that'll work too. Hypot's a little less typing. Arguably, it might be even a little faster. 3 and 4, 6 and 8. So there you go. Hypot is the Pythagorean theorem. One line. So that's a thing. And that is our lecture for today. So yeah, the algebra homework is due on Friday. Don't wait till the last minute, especially if you've never coded before. The only way you can really fail that assignment is by just waiting to the last minute and getting stuck and not knowing what to do and being baffled and lost. You should, especially if you've never coded before and you're not really sure how to compile things or write code, make an appointment with Mincarelli and go in and see him. Walker, Cabrera. There's a lot of really nice, helpful people here that can also help you out and get you going. It's not a hard assignment, and if you can't get that in, then the rest of the semester is not going to go very well for you. So make sure you get all that done. Get the zyBooks done by Monday as well. And then once you get all that done, start cranking on zyBooks week 2. And make sure you do it. Like I said, the stats are very clear that people who do the zyBooks, I've run the stats on my class. It translates into about a letter grade better on average on the tests and programming assignments and things like that. It does actually make a really big difference. Okay. So lesson for today. There are these things called functions, and you should use them. All right. We'll learn how to make our own functions in a week or two, something like that. But for now, yeah, just know there's some nice mathematical functions in there, and they make your life easy. All right. That's it for today. I'll see you guys on Friday.